Okay, welcome to another lesson with Mr. Clark. You're looking at river features for Hydrosphere. So today we're going to look at two different features, not just one that you've previously done. So we're going to look at meanders and then oxbow lakes. The two go well together, and you can in fact pick up marks for an oxbow lake question using points from a meanders question. So they're good ones to make sure you know the meander very well, specifically too. Reminder, 8 marks a question, 4 marks are available for explaining processes in detail. Example features are good practice. If you do have an example. Don't forget marks for processes, and we'll quickly talk about that in a second. Please go away and watch the videos here. One about meanders. Again, click on this photograph and it takes you to the BBC Bite Size page, and have a look at that little short 1 minute 45-second video. And then there is a knowledge booster GCSE level, remember it's lower than higher, which helps consolidate your knowledge. It is a particularly good video, so that's why I put these on there. Your diagrams, you're going to take 2 diagrams with all their notes today. The first one is a formation of a meander. There are 3 main pictures, 1, 2 and 3, that you'll be copying down, and you'll be taking notes around those. You'll need quite a bit of space for your meanders question. Definitely landscape page. If you've got a jotter, I would say a double page open spread with your diagrams, spread across those however you like to do that. We will be looking at an oxbow lake afterwards, so I do those on separate pages. Just to get us going, remember 4 marks for processes. I would focus specifically on hydraulic action and abrasion, explaining in detail how they work, where they work, and how they change a feature's shape, but that will happen within the answers you're given here. So what you've got going on the left hand side is this idea, or if you remember with V-shaped valleys, the erosion was going down. Here meanders are formed by sideways erosion, so we call the word we actually use this is lateral. You don't need to write sideways down, so if you know what that means. So meanders are formed by lateral erosion, by side to side. We're starting off here, and I'd probably label this diagram 1 a straight channel, a relatively straight channel, and what happens is the water's moving from the top to the bottom here. Probably should have put an arrow in, top to bottom. So in a straight river channel you get pools, so deeper bits, and riffles, these are shallower bits, and they develop as water twists and turns around obstructions in the river. You can't see any in the diagram here, but things like boulders or bits of bedrock stick up in a channel, and this results in areas of slower and faster water movement. So the key bit here is you're saying in a straight channel you get pools and riffles, and water turns and twists around obstructions, and that causes slow and fast moving water. That gets 1 mark. Pools are the deep bits of water, so I've got 2 on my diagram here. They could be in different size, that's just a model example. So they're deeper areas of water, and there is greater erosion there. There's less friction with the bed of the river because it's deeper, so that means water isn't slowed down, so there's less friction, and that's why we get greater erosion. Riffles are shallower bits. I guess you may have seen rapids, and that's the same kind of idea. We'll call those riffles. Riffles are shallower, there's greater turbulence. That just means that the water's kind of being thrown around or spinning or moving as it goes down all over the place, different directions. And they're created by deposition of coarse sediment. So in other words, lots of chunky bits of rock are dropped off. So deposition is where materials dropped off because of coarse sediment. Riffles and pools can lead to changes in the speed and depth of the river channel. Okay, we've kind of established that from our descriptions, but you need to make that clear. Once you have pools and riffles in a channel, the river starts to flow from side to side. It starts to become more of a lateral movement. So instead of flowing straight down the middle of the channel, with the pools and riffles you start to get the water moving from side to side in a winding course. I've not used the word meandering, which is something you could use, but it'd be better to say side to side or winding course. When that starts to happen, when water's going around a bend, it goes fastest on the outside of the bend and slowest on the inside. Just like if you were on a 100 or 400 meter track, you would want to be on the inside because it's a shorter distance. You don't have to run as fast. If you wanted to be level with the person on the outside, you'd have to be running faster. So it's the same idea. A river flows slowest on the inside of the bend, and that leads to deposition. So we've got really lots of things that marks to help explain how we get to a straight channel to what we call a winding channel, and that's when we get to start talking about the meander. So in actual fact, you've got 1, 2, 3, 4, 5, 6 marks just to get to talking about how the meander is forming in more detail potentially, but these are sometimes a bit more complicated. So if you wanted to maybe focus on some of the other marks we cover, I would maybe have that there as well. So diagram 2, I've reminded you, lateral erosion, sideways erosion, remember your marks of processes, but I wouldn't worry about copying down the blue points. They repeat what we've talked about, but they're not in an answer scheme format as I've got here. This is guaranteed to pick you up marks. So eventually the river transports the rocks downstream. Okay, so they're going to roll down the channel, in other words, and the channel becomes wider and deeper. Okay, in fact, I needed to remove this. This is an older version, so that's from another diagram, so you can ignore that. I'll put up some other points up in a bit, so ignore that. So your presentation will be correct, so just ignore this point. You can have a look at these ones. So the idea is we get deposition on the inside of the bend. You don't need to worry about being convex, it's a science term, we don't need that in the answer, and that's represented by these pixel or dotted area. You can put some dots. We call that a river, a slip-off slope, or a river beach. On this bit we call the river cliff. This is where it's a lot deeper, where the faster moving water is coming around the outside of the bend. Okay, so it's coming down the outside of the bend, and it's faster moving, so it causes erosion, hydraulic action, abrasion on the outside. We've got an AB cross section, and make sure that's in your diagram because I'm going to give you a note on the next page for that as well. So diagram 3, this is what we call helicoidal flow. So you'll have heard about that in the videos you saw there earlier on as well. So helicoidal flow, if you imagine a line of water, the fastest water is going to go around the outside of the bend, okay, through this section here. But as it does so, in actual fact, it doesn't move in a straight line, it doesn't move in a line, so it's not straight curves around the bend. But it doesn't move in a line, it moves in a corkscrew sort of manner. And that means if you were at any point along here, this is the action that's taking place. So water is actually, this corkscrew flow here is working like this if we did a cross section, and it's moving material from the outside of the river towards the inside. Okay, and that's what this explains here. So helicoidal flow, which is a corkscrew flow, moves material from the outside of one meander bend and drops it off or deposits it on the inside of the next. So that's what creates our river beach or our slip-off slope there. Okay, and the erosion leads to river cliffs, and deposition leads to slip-off slopes. That gets you a mark. Okay, so that's explained really how our meander is completely formed. And I know you haven't got particularly great notes on this page, but you can use some of these ones to help you as well. And the points we've covered already, that just really helps you see how this works. So your diagram's quite essential there, and you can choose where you want to put your labels. Okay, so there's A and B, so I put that onto that diagram too, so you've got that. I would make sure you've got that too. What I'll do now is I'll show you the next presentation, which is an oxbow lake, and we'll just do the same, and you can create your diagrams for that too. So as before, you've got your reminder. I'm not going to go through that, you can read that yourselves, same as it was last time. And those are your processes as a reminder, because it was in the first lesson on river processes and waterfalls that we went over those. Make sure you're aware of them, and they will collect you marks. Watch your two videos, one from BBC Bite Size if you click on the image, and the other one from a GCSE level explanation, which is particularly good and help consolidate your knowledge. So you're going to have three diagrams here, so have space on your page for 3 diagrams with notes around them. I would have noted here that in an exam, when you're explaining oxbow lakes, you need to be talking about meanders, because they only happen because of meandering, because the river is bending and these bends move outward as time goes on. So in other words, the meander will migrate. So the inside of the bend will grow and move this way, and the outside of the bend will erode and move this way. So if you've got two outside bends, which we've got here, the outside of the bend and outside of the bend with my cursor, they will erode into each other. So therefore eventually the river channel will just run straight right through and ignore this bit, and we get deposition, and this fills in. That creates our Oxbow Lake, and that's really how Oxbow Lake forms, but we need meandering to happen. So you can pick up a few marks, up to probably a maximum of 4, talking about a meander formation, but I would generally try and stick as close as you can to the key bits of a meander that are on this presentation here. So your diagram 1, as the outer banks of a meander continue to be eroded laterally, ask yourself what that means. If you're not sure, go back and have a look at the last presentation. I'll mention it on the next slide. So we have this lateral erosion, though processes such as hydraulic action, or through processes such as hydraulic action or abrasion, you're mentioning too, you get a mark, the neck of the meander becomes narrower. Okay, so make sure you've labelled neck of the meander on your diagram, so you know where that erosion process has taken place. That means you get 1 mark for just a list, because you said where it takes place, it gives you that relevant point, and 2 there. Next mark. Eventually, due to the narrowing of the neck in flood conditions, it's really important you mention flood conditions there. The water breaks through the neck, so it overtops the bank, or that neck here. The water would overtop in a flood. And what actually happens there, it breaks through, the 2 outer bends meet, and the river cuts through the neck of the meander, 1 mark. The water now takes its shortest route in a straight line, represented by that blue arrow of flow that I put in, rather than flowing around the bend as it did before. And that gets you a mark. The fastest current is now flowing down the middle of the channel. We get slightly slower water at the sides because we've got more friction with the riverbank. But as a result of that, okay, fastest flowing in the middle, in the straight line, we get more deposition on the outside of the bank, particularly in this really quiet area of water where the river's not flowing. And that means we get deposition because there's low energy. So we get dropping off of sediment, and that will eventually fill in. Okay, and it happens where water moves more slowly. So that's giving you a mark there as well. And that forms our cutoff, which you've labelled on your diagram there in blue. So that's it filled in. So due to deposition, the old meander bend is left isolated, keyword. So your old meander bend is left isolated from the main channel, and that's what we call the Oxbow Lake. That thing is the Oxbow Lake, looks like a C in this case. Continued deposition seals off the meander bend, forming a newer, straighter river channel, 1 mark. So continued deposition seals off the meander bend, forming a new channel, which is very straight. And that leaves the Oxbow Lake isolated. You could combine these to shorten the amount of texture writing. Over time, the Oxbow Lake may fill with sediment and dry up, except in really times of heavy rainfall, when it could fill back in a bit. So it could dry up, and we can see these scars on the landscapes, as you might have seen in pictures and videos that I've shown you already. And those are your 2 features for today, and please submit me 2 different pictures, one of your meander, one of your Oxbow Lake, with diagrams and notes around it, please. Any questions, send me a message on Google Classroom or an email.